Hi, everyone. Welcome to our second edition of Inside the Lab, where you have a chance to directly interact with some of our lab experts, some of my colleagues and good friends. So we're going to be taking your questions over the course of this particular webinar. You can directly put them in the chat box. We're going to hit upon a few particular categories, but overall, our focus today is to highlight cannabis applications. So some of the contaminants that customers are typically testing, the techniques they're using, and some of the solutions and tips that we've found to overcome common challenges. So with me today, I'm going to introduce my colleagues and allow them to give you a little bit of background, and then we'll jump into a specific set of categories. So talking about potency, residual solvents, terpene analysis, how to restart your lab. And then, a couple of other ones on the basis of specific contaminants also. So if each of you give a little bit of background about yourself. Shawn Orlowitz, Ram Kumar, Jay Preston, and Genevieve Hodgson are with us today. So Shawn, if you want to kick it off.
Sure, Simon, and thanks for moderating. So my name is Shawn Orlowitz. My current role is the Business Development Manager for Food and Cannabis for Phenomenex. I've been with Phenomenex. I started in 2003, actually, so I've done quite a few things here. But for about the last 2 years or so, I sort of lead the team in terms of strategies for workflows and solutions in the cannabis testing and manufacturing space. Everybody here is my colleague. We all work together on these things. But at the same time, I enjoy spending time in the laboratory as much as I possibly can. It's usually where I hide. So just working with clients and then taking it back into our laboratory, I think is what I bring to the panel today. Thanks, guys.
Ram?
Hey, Simon. Hello, everyone. My name is Ram Kumar Dandapani. I'm the Global Product Manager for Gas Chromatography here at Phenomenex. I've been with Phenomenex for around 6 years, and prior to that, I worked in pharmaceutical industry for around 7.5 to 8 years. One sudden day, I just did a Google search when I worked in pharma. I was looking for the keyword Snow, New Jersey, and then first or second in that list was my professor. His name was Nick Snow. That's how I came into United States. So it's a dream come true for me to come here, pursue my PhD. My academic and my professional focus was all on chromatography from the beginning. So I've done a lot of method development, method validation on HPLC and chiral methods in my pharma career, and then my PhD focused on multidimensional chromatographic techniques. I love to wear my bow tie. I was just looking for a reason to wear them, and here's a perfect opportunity.
Thank you, Ram. Genevieve?
Hi, guys. My name is Genevieve Hodgson. I am a member of the technical team at Phenomenex. I've been a member, I think, like you guys, I'm like the newest member here. I've only been with Phenomenex like 2.5 years, but I love it. I wiggled my way into Phenomenex. I went there on a tour once and I loved it. I fell in love and I was like, I have to work at this company. Before I was at Phenomenex, I worked for a company called Cerilliant that made analytical standards. That's where I learned all of my analytical chemistry in R&D and QC, and I did primarily a lot of pharma, but we started working with THC a long time ago and making standards then. And so I've been in the industry for about 10 years now, and I help troubleshoot customers problems and help provide technical support to our sales.
Thank you. Jay?
All right. Well, welcome everybody to this. My name is Jay Preston, and I have been at Phenomenex somewhere in the middle of this group, almost exactly in the middle of this group. I've been here about 9 years. So in my role here, I've had a variety, like Shawn said. I've been a application scientist, a product manager, now I currently run the applications lab. Before coming to Phenomenex is where my specialty kicks in for this particular group. I had about 17 years working in pharma, working at places like Abbott, Pfizer, Amgen, places like that. When I was at Amgen, I ran their small molecule large-scale purification group. That's the expertise that I'm bringing to this panel, is that prep and flash and isolation and remediation, however you want to deal with it. I've done everything from, microgram to milligram scale isolations of small impurities and things to multi-kilo purifications of chiral compounds. And as Genevieve said, Phenomenex is a great place to work. I mean, where else do you get to come and just play with chromatography and toys all day long?
Thank you, Jay. Thank you, everyone. I actually forgot to introduce myself. So my name is Simon Lomas. I'm a manager of a product marketing group at Phenomenex. And add a little levity to this. My son, as always, I'll start with a story about him. He woke me up this morning, the cry of a hyena. So it's kind of a new day for me, a new sound coming out of him. So tomorrow brings us, might be a pterodactyl or something else. But
mine sounds like a steel pup.
Yeah. But as you can see too from my colleagues on the call today, we've stepped up our game. No longer one of us being in a car. Some of us looking like YouTube stars. So we'll also see where the next Inside the Lab takes us. But yeah, let's jump into some questions. I see some coming through. And I'm going to list out the categories we're going to start with. So the first one actually relates directly to potency. So I think we'll kind of head in that direction. I think that's a good place to start. So the first one, it looks like I'm going to head this towards Genevieve. We are working with cannabis consumables, run into a lot of matrix challenges. Do you have any good sample preparation or cleanup tips or suggestions?
Yeah, I mean, I've seen a number of things used. I've seen for like pesticides, mycotoxins, I've seen catchers be used pretty successfully, and we have some notes on it and some literature. Also, I've seen some Strata used before too, depending on what the end goal is. So yeah, I mean, a little bit of everything.
Perfect. I think you also answered the next question, which was, can catchers specifically be used for cannabis sample preparation, and then which particular matrices is that typically a good avenue to go with?
Yeah, I mean, I don't know if you want the catcher's product manager to, oh no, catcher's product managers. So I see catchers used pretty much with like the flower analysis. It's commonly used for pesticides and that kind of matrix when you're working with the whole blood, the whole flower.
Actually, Genevieve, could you or Ram paraphrase a little bit of just where catchers fits for people that are not aware of what catchers even is and where it could fit in their workflow?
Yeah, that's a great point. So catchers, quick, easy, quick, easy, rugged, quick, easy, cheap, effective, rugged, safe, right? So our catcher's product is called Rock, and we have the standard offerings for catchers. So it's a quick and easy way to target the matrix instead of the analytes, right? So a lot of the time in sample preparation, we're targeting one analyte or a few analytes for cleanup. This catchers is really good for when you have a wide variety of analytes. So for example, with pesticides, you have normally, hundreds of pesticides that you're looking for. It's hard to target all 100 pesticides at one time. So instead of targeting the pesticides, we're going to target the matrix and clean up the matrix, with regards to all of the kind of interferences that matrix can bring. So with catchers, that's the goal, is to target cleaning up the matrix specifically instead of the analytes. But in turn, it cleans up your sample.
To add to what Genevieve said, it's an excellent technique for multi-residue, multi-class analysis. There is actually two steps in Ketcher's process. One is the extraction step, and then the second one is the DSPE, which is the cleanup step. Depending on the sensitivity and depending on the analytes you're looking at, you could either do both the steps or just do one step and see how your recovery is.
Perfect. And it looks like we had a question to follow up on that. Is there a volume limitation? You know, like how many liters per hour?
It's more of an analytical, not really a prep kind of isolation part.
So meaning like if you're looking for like a large volume to clean up, is that what they were? Yeah, I think it would be a different technique, like Jay was saying. This one would be more geared towards smaller analytical sample sizes, you know, like 0.5 grams.
I think I might know where that comes from. So yeah, so you know, different states and jurisdictions and countries even have different requirements for minimum sample amount. And and some, in the case of flour, is as much as a gram or half a gram, which analytically is kind of a large amount. To answer the question, Ketchers can be scaled up to gram quantities. The volume gets a little large in terms, you know, when you do 10x dilutions, but absolutely, it works pretty well. In terms of manufacturing of like, you know, cleaning up, crude or something like that, no, we would use different techniques, and we'll probably talk about that later in this panel.
Hopefully.
Gotcha. Okay, and then a separate one in the cases where, you know, Ketchers actually, you know, causes specific issues with you know, target pesticides that are interest in terms of stability and recovery. What other avenues are good recommendations to take for sample prep?
I'll chime
Shawn,
in, I guess. So yeah, so Ketchers isn't perfect. Nothing is. So, you know, I live in the state of California that has pretty stringent requirements for pesticide testing. We're currently at about 66 analytes with reporting limits down to, you know, high parts per billion typically. Canada, who we work with quite closely and talk to every day, they even have more requirements of 96 pesticides down to, you know, 10 ppb type levels in many cases. So recovery and cleanup has to be balanced in order to hit those reporting limits. So the answer, so there are specific pesticides that interact with the DSPE step. Some examples are when you use like GCB, graphitized carbon black, things like chlorophenapir typically don't get very good recovery. So if chlorophenapir is, for example, a pesticide of interest, I wouldn't recommend that second DSPE step. And so the really moral to the story is Ketchers applies to a lot of states and jurisdictions, but as the lists get longer and more complex, you have to use even less selective techniques. And so getting into those, for Canada and for California, a lot of times in pesticide analysis, we're only doing a liquid extraction. It's the only technique in which we can really study the recoveries. That works really well for common matrices like flour and oils. When you get into edibles, things get very complex very fast. And this is how I'll bring potency in, kind of the original question is just maybe bring into like two things that are important sample preparation when preparing, whether it be potency or pesticide analysis. Edibles come in kind of two flavors and sometimes both flavors mixed. One is what I refer to as fatty matrices. So things with like milk chocolate, chocolate bars, they just have a lot of fats in them. And so you have to really be considerate of those lipids, because when you do a liquid extraction and then add solvent, those lipids precipitate. Kind of a problem in analytical chemistry. So you have to play with those, and we have some techniques and some recommendations. The other side is the carbohydrate side, right? If you have something that's got a lot of sugar in it, you have to address that as well, because carbohydrates in analytical chemistry can cause other problems. So there's no one ring to rule them all, as I like to say, but we do think about these things, and they're important in sample preparation. So that's why when you call us and you say, hey, how should I prepare my sample? We'll ask you, what state are you in? What country are you in? What's the matrix before we even recommend anything? And I'll let the panel chime in.
Yeah. Hey, Shawn, how much SPE work do you see in cannabis for pesticides? like targeted?
More and more. So again, I think it is a young market. Pesticide analysis is very challenging. And so in the beginning, we were really just sticking with liquid. To Genevieve's point, in states like Nevada and Colorado that have shorter lists of pesticides, catchers has been fantastic. Now, back to those fats and lipids, what things people are exploring, and we have some publications on this, or at least some co-publications, is actually using solid phase extraction to do the winterization or the de-waxing of the sample in liquid, rather than having to put in the freezer and filter it and all these other things. So more and more, to answer your question, Jay, we're seeing solid phase extraction being used. It's a good technique, but it's a more specific technique, so you have to know how to use it.
A little more intensive and slightly more costly.
Sure, but
time consuming too.
Yeah, and this is where we're all going with this, right? Is the matrix effects, whether it be potency, pesticides, whatever, the matrix affects all of these analysis, and we're just trying to limit that, right? And that's what cleaning the sample is.
I have some success
Brent,
with, sorry. Yeah, so I've seen some success with normal phase SP as well, especially for fatty matrix, Strata fluorosil type for really polar pesticides. It gives good recovery.
I should mention that Strata is our SPE product. This is our solid phase extraction product. And we have Strata, which is our silica based, and Strata X, which is our polymer based. So, and we see both used.
Shawn, this one's specifically for you. I like it. To start, nice beard. How long do you plan on keeping it?
Ooh, for those of you that maybe don't know me, I never have had a beard in my life. This is a new thing. I hate it, but I'm sticking it out. I don't know is the short answer. I'm the type of person that I'm gonna wake up one day and I'm gonna just be so frustrated about the itchiness that I'm just gonna shave it off. So, but for now, I'm holding on, guys. I mean, between that and my hair, my country western album will drop in like November. You guys should check it out.
Thank you, thank you. A little bit of levity from our customers. I love it.
It's something.
I'll just leave this one open to any of you who want to answer. So I need method separation for delta 9 THC and exo THC. How can this separation be accomplished?
Shawn, do you want to start with that? I know we've worked on it.
I want to give this one to Genevieve because I know she knows it.
All right.
Yeah.
Yeah, let's have some fun.
Yeah. I mean, exo THC is something that we have seen more questions on recently with regards to that separation from delta 9, which can be tricky. And we have a panel. I think it's up to 18, right? Cannabinoids now, right? Shawn, am I?
Yeah, 18, and I'm 18, working on about
right.
23. Jay knows I'm coming to the lab.
18 cannabinoids, and basically it comes down to pH sensitivity and a small percentage of, you need to be careful with pH, and you need to be careful with your percent of acetonitrile. And we have methods out there, and we have a good one on our Kinetics C18 2.6. I believe it's a 150 by 3.0. And that's the method that, right, somewhere along this. So we have a good method there. But what ends up happening is between different labs, it works, but these compounds, these cannabinoids, and I think Shawn has said it before, they're magical. They just are very interesting, and the smallest amount of change can really impact them. So, we have a method, and I believe it is with ammonium formate. pH, I think 2.9 is what we suggest, and acetonitrile. But when you get it into your lab, it might take some tweaking, right? You might have to change that ratio of acetonitrile slightly. You might have to change that ratio of pH slightly. just to really dial it in and get it to work on the system, because they do fluctuate and they do change, and they really have that pH sensitivity. Shawn, I don't know if you have anything to add.
Genevieve, fantastic. And yeah, maybe, and again, this is a fun conversation, so let's have it. I want to kind of dive into why that question was answered, and whoever asked it is a new friend of mine. There's really a lot of things going on, but a lot of this really relates to the 2018 Farm Bill. So the 2018 Farm Bill effectively defined hemp. It defined it as having less than 0.3% total THC. So if it's 0.31%, it's marijuana. If it's 0.28%, it is hemp. Really putting the importance on accurate quantitation for cannabinoids. Well, THC is not, it has many isomers. We've all heard of delta 8. And so the separation of delta 8 and delta 9 is very important, because if they were to coalute in a quantitative analysis, you may get a false positive, or you may get an elevated level of delta 9 THC and get that. We've known about delta 8 for a long time, but what we're finding is that there's new isomers that are coming up because of different manufacturing processes and even using semi-synthetic chemistries. New isomers are coming out of, or are showing up of delta 9 THC. One of those is exo-THC. It's where the double bond is on the methyl. There's another one in delta 10, and it's important to at least be able to separate these, because if you don't, and I can tell you from experience, they do coalute with delta 9. And so, and we're using UV detection as a retention time marker. Yeah, and again, they're isomers. Even if you were using mass spec, you wouldn't be able to tell the difference. So chromatographic separation of those THC isomers is becoming more and more and more important.
And it is challenging. It is a challenging. It's hard, and especially fitting, getting all of the cannabinoids on one method. It's not an easy thing, and I know people like to get a method handed to them and to run with it. And these guys are so sensitive that unfortunately, it does need to be dialed in a little bit sometimes. For the most part, it works, but those minor changes do really affect getting that baseline separation between the two that you would like, or between all of them. They kind of come out all together.
Yeah. Shawn, have we noticed any the different variants of the grown material that has more of these delta 10s and exos and things like that, or is that has anybody found them at really high percentages?
Not high percentages. At least I haven't seen it. And if you are attending and you have seen high percentages of THC isomers, please chime in. We'd love to hear about it. It's fascinating. No, but low percentages for sure. And again, we're talking about if the bar that we're setting is 0.3%,
yeah, pretty low.
You don't need much, right? And so exo is interesting because some people in the world are using semi-synthetic techniques to say convert the cannabinoids to each other. And in doing that, you can obviously have some byproducts. And you can imagine, again, we're all chromatographers on this call. And so it's always like the ability to separate, to resolve molecules using reverse phase chromatography that differ by the position of a double bond. Delta 8 is here, delta 9 is here, same molecule. I love that we can do that, right? And you can imagine in semi-synthetic or synthetic pathways, you're going to create other ones, and we have to be able to resolve them. To me, to Genevieve's point, it's hard, but it is fascinating.
Yeah, it's amazing.
It's cool.
I think Shawn has spent a lot of time with this method. It's your project, and it's fun. I mean, it is fascinating for us chromatographers to see, these small changes, like these small step changes. There was one study that I saw that you did, Shawn, where you're just changing tiny 1% acetonitrile. I mean, that's not a lot. I usually, when doing method development, doing 5% or 10% changes in acetonitrile, but this is and they move everywhere. They just kind of shift around, and I'm sure we'll be talking about it later, but it's fun to see those small changes and how they have such a big impact in these strange, fun cannabinoids.
Back to the topic of exo and delta 9 THC, do the regulations say that exo is not included as delta 9?
So I can't comment totally on regulations entirely because A, there are too many of them. Each state has its own regulations, each country does. So the only regulation I know that specifically mentions exo is the WHO, in which they listed out the unique cannabinoids. I've never heard of any jurisdiction requiring exo as part of analysis or anything. So let's be clear about that. Go ahead.
Comment on the Farm Bill, though. The Farm Bill specifies delta 9.
Well, it specifies delta 9 THC and THCA, the carboxylated version of delta 9. And the reason that is for the less involved is THCA, or the carboxylic acid, when you heat it, converts to delta 9. And so there is a calculation to use when you quantitate THC and THCA and how to get this total THC number. There's certainly some controversy around that calculation, and I won't get into it because that's not for us. But again, to answer the question, to the best of my knowledge, no, exo is not part of any regulations. But we're just pointing it out that both exo, THC, even delta 8, they pose a risk to co-elute with delta 9, and because they're isomers, they have similar UV spectra. Using UV and even mass spectrometry, if they were to co-elute, you would not be able to separate them, and so your quantitative number for delta 9 THC might be inflated. Good question, though.
Cool.
Hey, good, Shawn. I wanted to add to that, we can also do the exo and delta 9 by GC, but the fear here is get converted to the other form. That's why people generally go for a HPLC method. You can actually derivatize them and then use a ZB5MS type phase to analyze it, but to avoid false positives, and then HPLC is a better method.
Ram, I would be ignorant if I didn't point this out. You're absolutely right. The gold standard, the historic ways of analyzing cannabinoids is GC. Absolutely, and it's still being used. It's absolutely still being used. It does have the negative impact of in the inlet, you do get the decarboxylation to happen naturally, but in some cases, like in the analysis of hemp, that's actually a good thing because it automatically converts the carboxylated version into the THC, and so you don't have to do this fancy math. You can just quantitate on one analyte. So you bring up a very good point, and you're absolutely right about that.
That's right. Also, there are some optimization steps, especially in the inlet, where you can reduce the conversion if you need, or if you want to convert everything, you can amp up the temperature and then convert everything to what you desire to see.
Gotcha. Thank you, guys. So this one's a little bit different. Is it possible to combine mycotoxin potency methods into one method or column, or why not?
I have to think about that.
Yeah, I know I've gotten this one before. Customers were, everybody would like to combine everything as much as possible and really, get down to as few columns as they can, or if they can use one system and do two different methods on it. But for me, I think that one of the things, just talking it out, right? We typically do the microtoxins on I think I've seen the method on a polar C18, whereas the cannabinoids are on a C18. Thinking about optimizing those methods and getting them on one column on the same method, I don't think you could get them on the same method, but maybe on the same column. Shawn, I don't know if you have.
In thinking about it, and again, it's a great question, and I love this. That's why these panels are so fun. It's something I never thought about. And let me point out the reason I didn't think about it. Mycotoxins are typically done by LCMS because the sensitivity is required. Potency is typically done by HPLC UV because we're talking about percent level quantitation. You could absolutely convert both of those to LCMS. And I've definitely seen plenty of people run cannabinoids by LCMS. There's benefits to it, but there's negatives as well. You probably could combine them on the same column, but I would probably run 2 different runs. And the reason isn't necessarily chromatography, it's dynamic range. You're going to quantitate, you're going to have CBD or THC at percent levels, and then so you're going to have that linear curve, and then you're going to have mycotoxins down in nanogram per mil levels. I think from a quantitative aspect, it could be challenging. I'll leave one more point and again, if you ask the question, chime in. If you're asking about fluorescence, I'm interested, because you can do mycotoxin analysis by fluorescence. Absolutely. So we've talked about the possibility of having a UV detector in line with a fluorescence detector and then going maybe that direction with it. Never seen it done. I think it's a good idea, but there's plenty of good ideas that don't work very well. So if that's what you're talking about, I'd love to hear about it.
Shawn, I think your point on the dynamic range is really you might be able to get them to run on the same columns, but the conditions and the loading and how you deal with them are really quite different, especially if you are using the mass spec. You are not going to want to inject enough of a media or material that has potency determination onto a mass spec, because you'll foul it and contaminate and overload it. You'll want to bypass that front part. So then all of a sudden you now have a totally different method that has to go into the mass spec in order to see the mycotoxins at that level.
Yeah, and that actually brings up, maybe I mentioned it, but the benefit of running cannabinoids by LCMS. And admittedly, and if you've ever, I talk about this during podcasts all the time and things. I didn't like it at first. A year ago, I was like, don't run potency by mass spec. That's a horrible idea. I made comments like, why would you drive your Ferrari down the 405 and sit in traffic? I've changed my mind, and I've changed my mind because I've learned. You can run potency by LCMS, and there's a huge benefit to it in the fact that you can do huge dilutions. And dilution is the solution to pollution. The easiest and best way to reduce matrix effects ion suppression is with dilution. And so by being able to do 2,000 or 5,000x dilutions, I can actually reduce my matrix effects and do my potency analysis by LCMS. Using that same strategy, I would dilute my mycotoxins out. So that's another reason why I'm like, you could combine them chromatographically, likely, but I think the quantitation would be the biggest obstacle to overcome. So, but that's an opinion. I'd love to hear counterpoint.
No, I agree, and I think that you could do them on the same column, but the same method, or the same analysis. No, and with the method the potency method that you've been working on, Shawn, it is amenable to MS, because it does use the ammonium formate and formic acid, which is nice. It translates pretty easily to UV or MS analysis, which is just a nice thing that you've done.
I try to be considerate, Shawn, to go back to your point on the fluorescence and HPLC UV, it's a great point. UV is a non-destructive detector, so you could combine that with a more sensitive, more selective detector like either a fluorescence or a mass spec. So maybe whatever comes out of UV, you could actually split and then send a small portion to the mass spec as well.
Perfect. Let's see real quick. In potency measures, is it really important to keep the carboxy quants reflective of the product? What steps in sample prep have you seen the cause of conversion by accident or accidental heat?
Yeah, I'll chime in and I'll let a panelist combine. Yes, the answer is yes. Again, just starting at the high level and getting down. So as this plant is really evolving right now in the hands of humans. 15 years ago, we were growing plants illegally, usually, and we were just trying to push high THC numbers. With hemp, high CBD flowers have much more complex cannabinoid profiles typically. And then because of the market, the legalization, the decriminalization, we have cultivators growing high CBG plants and high CBN. Most of these cannabinoids have an acid version that grows naturally. And so understanding those mechanisms, quantitating on those acids is really important. And I would think that if you're working especially with flower, the acids are crucial in order to provide great information back to the client. getting into the methods I've seen that cause conversion, absolutely, we've seen it quite a bit, and the biggest cause I've seen is in homogenization. We have a plant. We have to homogenize it before we do extraction. It's an incredibly important step in order to get good quantitative results. And a lot of times we throw these things in a blender, and we throw them in a blender just blindly and turn it on and go get a cup of coffee and come back later. That generates a lot of heat, and decarboxylation occurs at a relatively low temperature. I mean, I'm not exactly an expert, but I think 120 to 140 degrees Celsius, you start to get decarbs happening. So it doesn't take a whole lot to decarb a cannabinoid. And I would say homogenization is the biggest source I've seen. I think freeze milling, even just adding dry ice to that homogenization technique can really improve some of those things. But everybody here has done a ton of sample prep where they try to manage the heat. I'll let other people talk.
Yeah, I think the dry ice, I have seen many people freeze sample and then grind it or use dry ice. That actually reduces a lot of combustion. Yeah, also optimizing the speed of the blender if possible, or like the time you spend on blending it, that would actually help prevent more combustion.
Cool. So here we had a question. I think this relates to carryover, more general LC question. So do you see ghosting THC or raised baseline after running hundreds of samples? And then probably how you can prevent that?
I'll tee this one up for Genevieve, but I'll give you a comment. Because yeah, again, back to we are running, regardless of the analysis you're doing. This could be pesticides, this could even be terpene analysis. In that sample is usually high % levels of some cannabinoid. That's why we're running it, right? And so when we have 20% levels of a single analyte in a sample, carryover is absolutely a concern. A lot of times we run isocratic methods in order to be fast. And so isocratic methods are more susceptible to carryover issues and ghost peaks than maybe other samples. And so there are lots, carryover is a huge concern in all of these analysis, because even if THC is the carryover and you're doing pesticide analysis, that carryover could cause ion suppression. There are lots of ways to reduce carryover, and I'll let Genevieve or anybody else to talk about the many techniques that we use.
I mean, first thing that I consider is I know that throughput is a concern for most labs. They want to be as productive as possible. At the same time, column care is important, and keeping your column, in optimal care. I think that it's important to I like to do it I did do this. I would like to clean my column every day at the end, take it through a cleaning cycle at a high percentage of organic, ramp through from water to organic, and be able to like flush off some of those higher higher log P, I shouldn't say that, but like higher hydrophobicity compounds that are maybe sticking or could be carrying over, and that just makes it so that the next day you're kind of starting equal. You've flushed your column, you've kind of reconditioned it or cleaned it so that it's going to be operating well the next day. So just a quick cleaning sequence. Preventative is better than reactive, right? If you can clean it, then that's going to be better than they're building up. So that's one thing that I do like to do. Yes, I understand, throughput and running these columns constantly, which we see often, but every so set, every maybe, I don't know, 500 injections or 100 injections, if you could put a cleaning cycle in there and just give it time to reset and flush out anything that might be sticking on, or salts, or any kind of matrix that could be sticking around. So preventing carryover, right? The next thing that I think about is needle washes. I think about optimizing your needle wash to reduce the amount of carryover, and that's going to take looking at it and doing some injections, test injections, and finding out what level of organic you need in that needle wash to help reduce that carryover, but at the same time not affect your chromatography in regards to peak shape. You know, you don't want it to be too strong to affect your peak shape, and that maybe that's a little out there, but sometimes if it is your needle wash is too strong, then you might see some peak shape issues or some more interesting things going on with your chromatography, especially since these are so sensitive. So optimizing your needle wash and then, you know, being able to do those studies where you have injections of your sample, you have injections of your standard, and then you do blank injections before and after, making sure that you're not having that carryover. So those are, and I think that, so those are kind of the first two things that I would think about. And then the third thing that I would think about, maybe with regards to carryover, but really for column care, is adding a pre-column and then keeping that pre-column. So our security guard would be our pre-column, which is a cartridge system, and being proactive with that cartridge system and with your maintenance of it, and really replacing that cartridge proactively to not allow, you know, the whole point of the cartridge is to keep any of the contaminants or particulates or these things that might be causing carryover, or not carryover, but ghost peaks, right? Any of these things out of the analytical column. And if you're not proactive in replacing that cartridge, then they build up on the cartridge and then eventually make their way to the column. And that's what you would like to prevent. So yeah, so being able to clean and really, you know, adding a cleaning sequence occasionally or every once in a while. Needle wash is very important. Optimizing that needle wash for your method and to reduce carryover, and then also maybe considering a security guard.
Yeah, I'll jump in with just sort of a tip there, that ghost peaks, you know, solid chromatography peaks that show up randomly in things, those tend to come from auto sampler issues. And then that rising baseline tends to come from fouling of the guard column or the column itself, as something's continuously bleeding off. But that's kind of a way to sort of narrow down what is your problem and where to focus.
That's a great point. So isolating where it is, and that's again where that testing would come into it. For me, as a troubleshooter, I like to, again, yeah, totally, Jay, isolate. Is it coming from, you know, the sample? Is it coming from the column? Is it coming from my mobile phase, maybe contaminants? Is it coming from the auto sampler? You know, and kind of taking each one at a time and focusing on it.
Okay, so carryover is not just a problem with LC. GC method might also have carryover issues, especially because of the matrix, especially because number of components in it, and then many times the sample is like so sticky. So that gives actually so much problem in GC. The transfer line can go only up to a certain temperature limit, and then anything that's higher boiling than the max transfer line temperature, it can actually accumulate in the transfer line, especially in headspace method, and can give carryover. So I think when you do a method optimization, it's very important we do standard as well as sample, real sample spike to optimize, make sure recovery is good, make sure we don't see like extra peaks, make sure we don't get carryovers.
Perfect. Thank you guys. Jay, I'm going to send this one your way.
All right.
I see pesticides are a real issue, but I'm a cannabinoid focused scientist. Have you run any chiral analysis of cannabinoid extracts? In particular, what range of ratios have you seen for CBC?
So we have run not very many real samples in order to see whether natural products are chiral or not. We have purchased standards from several different vendors, and some of those are synthetic, and they come in as racemic mixtures, actually, because they were synthesized. We have found we've had really good luck with the Lux Cell 2 column for all of the cannabinoids. not just from a chiral standpoint, but from an achiral, because what are you trying to do? Is you're trying to separate very closely related things in a chiral column. That's what it does best. So we tend to recommend cell 2 for a lot of cannabinoid issues. We've had a little success with amylose 1 being another good column for it. But in pesticides, chiral pesticides is another big deal, but that would be a commercially available pesticide, and that should have already been set earlier in the where it was purchased. The manufacturer of the pesticide should take care of that. But that's a whole area that we have done a fair amount of chiral pesticide work, but mostly geared at the agri-science industry, not so much from the cannabis part.
Cool. Thank you. Ram, I'm going to shoot this one your way. Pesticide analysis, definitely challenging in what's laid out there and what's needed to be analyzed. What are some tips you can provide to help us get our method up and running?
Sure. So pesticide analysis, as Shawn mentioned before, there are different guidelines from different regions. So the set of pesticide is going to differ. And then the ionization of these pesticide is also going to differ. The concentration levels people are looking at are at different levels. So it's not a one technique solution per se. I would combine LC and GC for pesticide analysis because many pesticides actually give good profile on LCMS, while there are some pesticides that might not ionize even in a positive and negative mode. And then for those cases, we can always do a GC. With GC specifically, there are some challenges. One is the activity in the liner. So make sure to have a premium deactivated liner with a thicker film of deactivated coating. A good example is Zabron Plus liners. These have thicker deactivated coating. If you take a regular liner, you might have active spots. It's basically solenols, and then the analyte actually absorbs in the liner and it would not make its way to the column. The second point is the actual column itself. You need to go for a premium deactivated column, be it a 5 or a specially designed pesticide-based column. Go for a premium deactivated column because there are some pesticides that would actually break down in the inlet. We have seen this in many other methods in food, in environmental, Endrin, DDT, all these pesticides. It would just break down 30 to 40% in the inlet itself. So our Zabron Plus range of columns or premium deactivated, a 5MS Plus would be an excellent choice for a generic selectivity. If you want to go for a more selective pesticide-based column, you would get even better chromatographic resolution. ZB multi-residue 1 and 2 are good examples of pesticide-specific columns.
So maybe I'll add to this. Sorry, Ram,
go ahead.
You want to say more?
Yeah, so one more thing is why would I choose a 5 versus a more specific pesticide-based column? Many times people do a cultures on an acetonitrile extraction. Acetonitrile, so to say, is not a very friendly solvent for a GC column, especially if you're doing a 5MS, because it wouldn't wet the surface of the column. 5MS is a non-polar stationary phase, while your acetonitrile has a little bit of polarity. So you will have a flooded zone inside the column that's not wetting the surface. So the initial peaks, you might have a struggle in reproducibility. When you go for a multi-residue column, it's a mid-polar selectivity. So you will get sharper peak shape for a really polar as well as mid-polar pesticides, as well as the solvent focusing would also be taken care of.
Thank you, Ram. I don't know if Genevieve, Shawn, or Jay, if you guys want to elaborate on, commonalities you've seen about labs either using GCMS or tandem LC or pesticides.
I'll start just because of 2 points. That last point that Ram just said is really important and a lot of people miss. When we're doing sample prep, again, I tend to think of laboratory workflow, how a sample moves. A lot of times we're doing acetonitrile extractions. We then split the sample into 2. One's going to go to LCMS, one's going to go to GCMS, and we a lot of times I should say a lot of times, but what's common is that people will take the GC aliquot and do DSPE on it to clean it up, because on the GC pesticide list, they can do that and get good recoveries. He brings up using acetonitrile on a GC, you have to think about it because it does present new challenges. And I think he brings up a fantastic point about the multi-residue column in that workflow, just to kind of highlight it. That's a great tip and one of the things that we've come to learn over the years. In terms of LC versus GC, I think the unique thing about everybody on this call is we're Phenomenex. We have GC columns, we have LC columns, everything works. In a unique world, if it were my laboratory, I would have an LC triple quad sit next to a GC triple quad. But we also understand those two pieces of equipment are very expensive, so you may not be able to have both. So the state or government requirements in terms of the list is kind of where I start and say, okay, can we do all these on one technique? And then I look at the matrices we're going to use, and then I look at the problem children. And a couple problem children, some jurisdictions, specifically Canada, California, again, have really polar pesticides, diminizide, acephate, that if you're going to do LC triple quad analysis on, you need a polar phase to retain them. I mean, in my experience, diminizide, it comes out in the void of a lot of pesticide method, bad peak shape, hard to quantitate. We've found chromatographic ways of retaining that good peak shape and better quantitation. If we're going to talk about pesticides and problem children, I would be ignorant if I didn't bring up our good friend chlordane. Chlordane is a beast, and everybody just went, yeah, and I'm sure everybody at home is going, yeah. Chlordane works great by GC, and so if you have the ability to hit your sensitivity requirements by GC, fantastic, it works. It's so there's benefits on both sides of it, and there's challenges on both sides of it. Is kind of the end call. But at the end of the day, for everybody attending, with all these questions about pesticides, rely on your resources. We are just some of them. There are a lot out there, but a lot of us are focused on this every day. And the first people say, they're like, when they ask me, they're like, hey, Shawn, I want to get pesticides up and running. What do you suggest? They said, talk to all your friends, talk to your network, bring in the vendors. We know a lot. We can help.
Well, it looks like I got a question in relation to the acetonitrile problem. So can you use a PTV to remove the acetonitrile problem in the column?
I'll let Ram.
So yeah, I think they're asking, like, can we do a programmed temperature vaporization? So PTV is mostly for fractionating the analyte in the inlet, right? And then if you want to vent the actual solvent out, that's a good idea. However, there are way more simpler steps than that. You could just go for a little more polar column, and that would give like better selectivity for your analytes as well. So that I would consider that as an easier way. Again, anytime you go for a cool-on column injection or PTV, there is a lot of optimization step. I was reading an article the other day on PTV. It says like there are around like 8 to 9 different correlated parameters that you have to optimize. It's the flow inside the inlet, flow in the column, temperature, all those, and then the right fraction has to go inside the column. So just in a fraction of a second, you can actually miss the actual analyte and then send something else. So I think a faster and more efficient way would be to go for a column that's mid-polar.
And again, I just want to chime in that from a troubleshooting aspect, because that's usually what I do all day, the more variables that you add, the more things that could go wrong. So, if you have the ability to streamline it and make it simpler, and avoid anything that could go wrong, right? Adding more variables. I don't know. I respect that. I like that.
Perfect. Thank you. Okay, I think we're switch it up real quick and head into another topic on THC remediation. So maybe Genevieve, I'll throw this back your way, and Jay, definitely chime in on this one. So been researching chromatography as a technique for THC and pesticide remediation. This seems complex and expensive. I guess tips and how people are using this technique.
I mean, yeah, I'll pass it to Jay because he did most of the research and I've just seen the research and worked with it, but he was the one that really performed most of it.
Yeah, so you're right, or the question is right, Simon, that chromatography at the large scale can be complex and expensive and difficult to do, but it doesn't have to be. It can be done at a reasonable way if you set your expectations right. If you're trying to do large scale chromatography to isolate out every single terpene and every single cannabinoid out of a complex mixture, yes, you're going to need very expensive equipment, very expensive columns, and have a lot of time, money, effort put into that. But it is possible, and we can isolate, as much as you want and as fine as you want from the different structures. If you can separate them analytically, we can probably separate them at prep and isolate them out. But it'll cost. If you're only trying to isolate and remove THC from your large things, there are other techniques that you can do that are more cost effective, faster, easier, cheaper. And this is where it gets a little gray in the chromatography world. If you're still talking prep chromatography, are you talking flash chromatography? Are you talking almost some kind of big SPE column that's just specifically trying to get rid of the THC from you? And essentially, they're all about the same thing. But I had a poster at PitCon recently, which was one of the last conferences to actually meet in person this year. But we demonstrated on an analytical scale, the THC peak and how you could load it up and remove it. We demonstrated on an Axia column how you could load it up and remove it, and then also catch all the different cannabinoids as you're going along. But on a flash cartridge of how you can still easily separate THC, and it kind of comes with the XO and the Delta 8 and all those sort of form one big group. You get rid of them all at the same time. But you can take that technology, and there are ways of doing that where you're starting to turn it into more of an SMB type, where you're continually loading and pulling it off as you're going through. It's a little complicated to explain in the last 4 minutes of this webinar, but it is a way of doing it, and it depends on what you're wanting to do. If you're only looking to remove THC, you can set that up as a way to process multi-kilos a day without a whole lot of complicated effort. I mean, it costs some money to get started, but once you get it up and going, it can be very cost effective. If you really want to isolate out all the different ones, now we're talking a lot more effort and a lot more time, but there are ways to work within the framework that your industry is set up as.
I know. I just wanted to mention though that that the poster, I believe, had ethanol used as the solvent of choice. It was water and ethanol, which is a little bit more friendly to going to consumers after, I believe, if I have it correct. So I mean, because acetonitrile is typically used. But in this case, ethanol was used, which is better for us, I think.
Yeah. Well, the use of ethanol is great because then the residual solvent testing and limits and things, really becomes less problematic. And the cost. I mean, ethanol, good quality ethanol is not cheap. Just think of some kind of old bottle of whiskey, not just commercial ethanol that we're talking about here. But acetonitrile is expensive, and it's toxic, and it's more of a hazard that you have to worry about down the road.
And there are shortages as well sometimes.
Yeah, so Jay is suggesting using moonshine as mobile phase. That's the first thing. That's the first time I've heard that in my life. But
I was going to use hand sanitizer. I thought just gallons of it, right?
A little thick.
And just to kind of chime in and hopefully wrap that up is, so we work with a lot of tolling organizations in which they're doing THC remediation. And you're right, there's a complexity to it, especially when you make it relative to like CBD crystallization and normal practices today. In terms of expensive though, when I look at some of the tangential or other technologies that are used for these things, on a large scale, I would argue chromatography is one of the least expensive, to be honest. and simultaneously it's one of the most versatile. So every crude, every distillate, every mother liquor is a little different, and we need to handle them differently in terms of doing any remediation. The nice thing about chromatography is it's chromatography. It scales well, it's versatile. If I want to do THC remediation today and then on the same media possibly do pesticide remediation tomorrow, I can. Whereas some of the other technologies are not quite as versatile. So I think chromatography has a bright future in that remediation world.
Cool. On that note, I think I'll kind of close this up. To give a big thanks to everyone on the call who joined us today. If we didn't get to your questions, you're absolutely going to get an email back or a chat back from us to answer your questions. It's nice to have some fun, friendly colleagues with me to share this moment with you all. Obviously we hope you're all staying safe and sane at home, and increasing your knowledge on what's going on in the world every minute, every day, and holding your family close and your friends close too. Again, if you have other questions that you didn't include with us, definitely reach out to us through our Chat Now program. That way you'll talk to our technical team right away, and look out for our future. Yeah, you'll talk to Genevieve right away. And look out for our future Inside the Lab webinars focusing on other topics. But thank you again, and goodbye.
Thanks, everyone.
Thank you.